Okay, y'all, so time to get started today. We're moving on to a new topic, which is design of database, so database design. And we're spending the next 2 weeks on it. There's basically two ways you can go about doing design. There's a top-down design approach that uses something called entity relationship modeling, or abbreviated ER. And there is bottom-up design, which uses a technique called normalization. And what I find is that usually most people are more comfortable using top-down design to design the database, but then it's often a good idea to use the normalization approach to check your assumptions with the relations that you've designed. So the idea is that you're trying to, with the design, you're trying to ultimately derive the relations that you will use in your database. And of course, with those relations, you also have integrity constraints, attributes, and the like. So basically, the design step precedes the DDL step. Once you have your design, you can hand that to a database administrator, and they would implement it using the DDL. So we're going to spend 1 week on ER, or entity relationship modeling, and 1 week on normalization. And in each case, what we're going to do is spend a day talking about the basic concepts, and then the second day will be devoted to analyzing a case study. And the reason I've done it this way is that the first 2 times I taught the course, students really struggled on exams with with design, and I decided that the best way to counteract that was to go over a complete kind of case study in each case to show you how it's done. It seemed like a lot of students were having trouble getting their heads around the whole thing. They could kind of understand the individual parts as I present the details, but seeing the whole picture was kind of elusive. So that's why I do it this way. Okay. So that's where we're going. And, So, as I said, ER stands for Entity Relationship Modeling, and the objectives of today's lecture is showing you how it's used in database design, showing the diagrammetric language that is associated with it. You often hear it referred to as UML, stands for Unified Modeling Language, and we aren't going over all of the parts of it. There's a second chapter that goes into advanced concepts of the ER model. We're just doing the basic ones, kind of giving you the 80-20 rule, that with 20% of the effort, you get 80% of the value. And then there's a couple problems that commonly occur when you design a database, and we'll talk about those so-called problems, which are often called connection traps. So there's 3 basic concepts in the ER model. Entity types, which essentially are going to be your relations. And then there are what are called relationship types. And relationship types are actually, well, they express some kind of relation between 2 things. For example, a branch employs staff. And usually the way that a relationship type is manifested is as a foreign key in a relation. So for example, every staff member has a branch number in their tuple, and the branch number, whoops, you can't see it. Just a second. Is that going to work? Well, that works, but it doesn't give me what I want either. Hold up 1 second. Okay, so as I was saying, relationship types, basically, whenever you see a foreign key in a relation, it means that that relation has some type of relationship with the relation that the foreign key points to. And then obviously attributes are just about defining the attributes for each of the types. And essentially entities map to relations. And so we distinguish between an entity type and an entity occurrence. So it's just like in object-oriented programming, we have a class versus an instance of a class, so the same idea. And then we have things that are entities that have a physical existence, like staff or customers or parts. And then those things that have a conceptual existence, such as a viewing of a property, an inspection of a house, a sale of a product, or your work experience. Now, oftentimes, things that are conceptual will turn out to also be relationships. So really, a viewing is a relationship between a customer and a property. We say that a customer views a property, or one of our staff inspects a property. So in many cases, conceptual existence is actually going to really be a relationship, but it may get mapped into a relation when we create our relations. Now, work experience would actually probably be an actual actual entity. It's not a relationship. So in the unified modeling language, an entity is represented as a rectangle with a label in the middle. So staff and branch are two entities. And then the important thing in the design of the database is defining your relationships between your types, because when you decide what your relationship types are, you're really deciding what your foreign keys are. Okay, and as an example, this is how it's illustrated. You put a line with an arrow and the relationship name on it between the two entities. So in this case, we say branch has staff. Now, this was a bad example of a relationship name. In general, you should, A, not duplicate relationship names, and I see this all the time in homework assignments, is you can't come up with anything better than has. That's no good. The reason we don't want you to duplicate relationship names is it makes it ambiguous when you talk about it with group members. If I say, well, this has relationship is really giving us trouble, 4 other people look at you and say, well, we have 10 has relationships. Which one do you mean? So just like duplicating variable names isn't allowed in a language, if you duplicate your relationship names on your homework assignment, we will deduct points. The second thing is it's good to use action verbs to describe your relationships. And this definitely is not an action verb. So it would be better to say something like a branch employs staff, for example. And there's often a question of which way to orient the arrow. Do you orient it toward staff or do you orient it toward branch? And a good rule of thumb is that you draw the arrow Well, we can talk about, first of all, the number of times something occurs in the relationship. So one branch can have many staff, whereas one staff member belongs to exactly one branch. So when we have what we call a one-to-many relationship, we typically draw the arrow from the one to the many. So in this case, a branch can employ many staff. So we draw it from the branch to the staff. Notice I could have drawn it the other way. I could say staff is employed by branch. So there's no right or wrong way to do it. These are general style guidelines. Okay, so in general, draw arrows, draw relationship arrows from the, I'll call it one entity, to the many entity. And another way that you can think about it is that you tend to draw the arrow to the entity that will store the foreign key. So in this case, it's the staff relation that has the branch number as a foreign key. So that's another indication that the arrow is going to be drawn to the staff entity. Okay, and as I said, we talk about the degree of a relationship. The one between branch and staff is one to many because one instance of a branch employs multiple instances of staff. So we call it a one-to-many relationship. Then an orthogonal axis is the relationship of the, oh wait, I messed that up, I'm sorry. In this case, we're talking about something else. In this case, the degree of a relationship is the number of entities that participate in it. So normally it's binary. So this is a binary relationship, but sometimes you have more than two entities participating. So we call 3 in a relationship a ternary relationship, 4 a quaternary, and so on. So here's another example of a binary relationship. We have property owner owns some number of properties. Here's an example of a ternary relationship. So staff registers a client at a branch. So there are 3 participants in that relationship. Another one is in our hotel database, a guest books a room at a hotel. And a third example would be a customer leases a property from an owner, or a customer leases a property from a staff member. So you can have, in fact, that could be a quaternary one. A staff member leases a home to a customer, and the home might be owned by a private owner. So that may be a 4-way relationship between the staff member, the owner, the home, and the client. Now, this causes the biggest problem of anything. Many of you want to write a ternary relationship like that so that it actually looks like 3 two-way relationships or 3 binary relationships. So you say a guest has one or more. You might say a guest, whoops, you can't see what I'm doing. You might say that a guest books one or more rooms. And you might say that a hotel let's see, has reservations. I'm going to use has because I can't think of a better one there. And then we have room. See, I'm even having trouble coming up with names here because I want to use the same verbs each time. I want to use books. Room, I'll say occupied. Even though occupy is not really, reserved is a good one. Reserves bookings. But see, it's not really right, reserves bookings. At any rate, first of all, it's hard to come up with good names. And second of all, this obscures the fact that a guest books a room at a hotel. Instead, it just looks like a guest has bookings, a hotel has bookings, a room has bookings, and it obscures the fact that it's really a 3-way relationship between the 3. And generally, when you have one-to-many relationships all coming into the same entity, there's a good chance that that is a relationship, not an entity, and that you need to rethink your diagram. And another good way is so normally when you're designing these ER diagrams, you don't already have the relations. But in some of the problems we've gone over, you already have the relations. So you know that a booking has a room number, a guest number, and a hotel number as part of it. And when a relationship has more than one foreign key, there's a good chance it has a ternary or quaternary relationship with all of those keys, rather than binary relationships with each of them. So if you end up with a relation that has multiple foreign keys, often that means there's some kind of relationship among those foreign keys. Okay, so if you have a relation with multiple foreign keys, there is a good chance that the relation describes a relationship among those keys. Not always, but there's a good chance. And you might want to reconsider your entity relationship diagram in that case if you've drawn it something like that. Okay, so when you have a relationship that is that's a binary, it's not a binary relationship, so more than 2 entities participate in it, you draw the relation as a diamond, and you name the relationship, and then you have lines undirected lines coming into that relation. Whereas when you have a binary relationship, you don't have the diamond. You just draw a line straight from one relation or one entity to the other entity, and you direct it and put the label of the relationship on the line. Okay? And here is an example of a quaternary relationship. So this might be where a solicitor at some bank arranges for a financial institute, for a buyer to make a bid on some financial institution. Or, as I said, you could say that a staff member arranges for a customer to rent a house from a private owner. That would be another example of a quaternary relationship. So then there's some other things about relationships. So sometimes you have what's called a recursive relationship, where both ends of the relationship are the same entity. So an example would be a staff member who supervises other staff members, so a manager, essentially. So in this case, it's called a recursive relationship because the line goes back to the entity itself. And in this case, you name the relationship like you did before, but then you also, on both ends of it, right here and right there, you name the two different roles. So in this case, the supervisor is one role, and the other role is supervising name. Whereas normally you don't put in the names of the roles because it's obvious. But with a recursive relationship, you kind of have to name what the two different roles are. And then you can actually have relationships that go in both directions. So here we have the previous one of branch has staff, but then also a branch is often managed by some staff member. So we have the opposite where the staff manages branch. And in this case, you also typically label the roles so that someone reading the diagram is able to determine what the difference between the two relationships is. Now, this isn't as hard set of a rule, but it can still help so that someone looking at these two lines has a better idea of what the difference is between these two relationships. So it looks like a circular graph, and it is, but they're two distinct relationships. Okay, so questions about relationships. Okay, so I have some exercises for you. So we've had a couple ones. We've had courses, relations, courses, students, and student courses. And this was something like had a course ID and a course name. And this was something like a student name, student ID, maybe a student GPA. This one had a course ID and a student ID. So, I want you to take a couple minutes and figure out what kind of entity relationship diagram you would draw for this very simple database, given that those are the three relations. Does anyone want to take a crack at it? Okay, so what do we think are the entities here? Philip, I'll ask you. What do you think are the entities here? No, just the entities. So the first thing you have to do when you are designing an entity relationship diagram is decide what your entities are, the boxes, the rectangular boxes. Okay. Okay. So if you're not going to make student courses an entity, what is it? Okay, you think it's an entity, except that it has multiple foreign keys. Okay, so you think it should be a three-way relationship, but not this way. You want me to make it a diamond. Like that, and call it student courses. Except with a binary relationship, you don't make a diamond. You only use a diamond for ternary. You only use it if it's a ternary. So there's only two entities coming into this relation. Therefore, it would be a binary relation. If there's only two entities coming into a relationship, then it's binary. Okay, so in fact, trying to find my eraser here. Not finding my eraser. Huh. Why won't it give me an eraser? Where? Here? I don't think that's an eraser, though. Maybe it is. Let's see. Ooh, it is an eraser. Okay. So, actually, this is the relationship. So we say students enroll, if I could get it right, enroll in courses. So in fact, this student courses is really an enrollment relationship. It's not an entity. Now it gets crystallized as a relation, but it is not an entity. It is a relationship. Students enroll in courses. Now we call this a many-many relationship because a student may enroll in one or more courses, and a course may have one or more students. So we call this a many-many relationship because multiple instances can appear on both sides. Okay. Yes. So in this case, yes, it tipped me off that because it had two foreign keys, there was likely some kind of relationship involved. And when I thought about it, I realized it's an enrollment relationship, that students enroll in courses. So this is a bit of a bottom-up approach because actually I already had the relations in this case, and I asked you to draw the entity relationship diagram. Often, you would not yet have the relationship when you actually drew the ER diagram because it would be top-down, and you would just have to figure out that there is this relationship between students and courses. Okay? Now, let's make it a little more realistic. So actually, a course often has multiple what? Sections. So you actually are more likely to have another thing in here, which would be sections. So probably would have something like a course ID and maybe a room number and some other information. Okay, probably would have also a section ID. So that would probably change up our thing, because probably if we were doing an entity relationship diagram, we would now say, okay, a course offers sections and we could treat it two-way. Oh, geez, I hate that big thing. Okay, so now we can think of students enroll in sections. Okay. And if we crystallized it, we would probably, this enroll in relationship would still be crystallized as a relation. We would probably have something like enrollment, have a section ID, and a student ID. And then, well, sections is, in this case, an entity.
Oh, I see it.
Okay, so sections is an actual entity. It's you have multiple sections associated with a course. Okay, it takes a little getting used to, yes.
So the direction of your arrow is really dependent upon the verb.
Your verb, yes. Another way to think of it is the direction of the arrow tends to be determined by your verb. Philip.
So your arrow selection this time is different than what you previously said. So you said many to one. So
No, so it goes from one to many.
okay.
So a course offers one or more
Right. So there's one course, but there's many sections
of that course.
But there's one section that has many students. So wouldn't the arrow be the opposite direction?
So a student can enroll in multiple sections, right, for different courses. So this is listing not just the sections of one course, it's listing all sections of all courses. So it's listing sections of math courses, sections of computer science courses, sections of English courses. So a student can enroll in one or more sections. You're right, they can only enroll in one section of one course, but they can enroll in one section of CS 465 and one section of CS 360 and one section of Math 140. So they can enroll in multiple sections, and then, like you say, a section can have multiple students. So in a many-many relationship, it could go either way. If I could have, alternately, I could have said sections enrolls students. Either way is fine in this case. In a many-many relationship, the arrow can go either way. It just depends on the verb you use. Other questions? Okay. Now, actually, that does bring up kind of a good thing, which is you kind of were thinking, well, a student can enroll in only one course, right? So you might, as the designer, decide, okay, I want to kind of indicate that a student can only enroll in one course, section of one course. So you might actually decide that this is a ternary between these three to try to drive home the point that a student enrolls in a section of a course. And that's kind of an integrity constraint. You don't want a student to be able to enroll in two sections of the same course. So as a designer, after you got done with the original diagram, you might step back and say, well, wait a minute, I really don't like this idea of just arbitrary, a student being able to enroll in multiple sections of the same course. How do I enforce a constraint? You realize then, well, hey, maybe you also have to add courses as a third element of that relationship. But then, depending on things, you really, when you actually crystallize that relationship as a relation, you really don't need to put course ID into this particular thing. And the reason is, why? Why don't you need the course ID in here? Because if I go to section ID, I can find it up there. So when you actually crystallize it, it would actually only contain really the section ID and the student ID. But these are all matters of style, okay? Sometimes I think there's really a right answer and a wrong answer, and then other times I think it depends. It's on the one hand, on the other hand. Okay? So here I think you could make a good case for either a ternary relationship or a binary relationship. Okay? So give it another try. Now we have rooms and guests and bookings and hotels. Pardon? Well, I gave you one of the relationships. I may not have given you all the relationships. So I certainly gave away kind of the fact that hotel, guests, and rooms has a ternary relationship. But are there any other relationships? Pardon? Hotel in the middle. So where should... Hotel is an entity, so it can't be a relationship. But there is another relationship. Hotel has rooms, or hotel offers.
Yeah.
Okay, a hotel offers one or more rooms. And if you remember, the room has the hotel number as a foreign key. So that would be a strong indicator that there is a relationship there from hotel to rooms. William. Mm-hmm. So it is true that if you gave the room a unique ID, you could kind of say that, but there's still, the way this designer set it up, okay, or the way the book set it up, this is the way the relationship would be indicated. And actually, even if you gave it, it's true that if you, let's see, think about this for a moment. If you said bookings and you gave each room a unique key, so each room has a unique key, and it's just a guest. And now you could, sure, but, gosh, I hate this big. It didn't used to be that big. At any rate, you have to decide whether it's right or not to assign a unique room ID. I would argue that when you're doing it top down, there really, honest to goodness, is a relationship between a hotel, a room, and a guest, and so that's how you should show it. It's not really a relationship between a guest and a room because that obscures the fact that that room belongs to a hotel. So I think a lot of people in the field would argue you really should still, you don't want to reduce everything to binary relationships because often that obscures important information. So that said, you're right, you could do it that way, but I think a lot of people wouldn't like it. Right. Mm-hmm. That's true. I could have, I guess, said that a section has a, yep, I see what you're saying. I guess I'll leave it at the, if I didn't have sections here, I would probably, another thing a university has is rooms. So then I might end up with rooms somehow in a ternary relationship. So even if, it's more complicated than what I showed here because there's also probably rooms. So I didn't show the whole picture here. Okay. At any rate, I'm sticking with it. A booking is really a relationship between a guest, a room, and a hotel. Because the person is still going into a hotel. It's not like so I would have more sympathy for it if you were talking about an Airbnb, where each place has only maybe one room. Okay? But here, rooms are part of the hotel. So the guest is going to the hotel. So I'd say the relationship is more than just with the room. It's the guest is going to the Holiday Inn. So I would still claim that even if eventually you assigned a room a unique ID, it's right to show the booking relationship as a three-way relationship. Okay? Other questions? Yes.
So the binary relationships have something that indicates the direction of the arrow. Why is the ternary not having a direction?
Because there's not necessarily, because it would imply that you have three things ganging up on one, and there's not necessarily a directionality, like guests book a room in a hotel. So should the arrow go to hotel or should it go to room? Pardon? Or should it go to guest? I mean, that's the thing. I think it's more ambiguous. But Greg, honestly, I don't know. I've never actually, I'm speculating. I don't know for a fact why they don't direct the edges in ternary relationships. But I think it's because it's more ambiguous. Mm-hmm. Other questions? Okay. Okay, so pretty much we already know about attributes. However, there are a couple things we haven't talked about with attributes. One is the difference between a simple attribute and a composite attribute. So a composite attribute could be something like a street address, 1678 Cardiff Road, Knoxville, Tennessee, 37920. So the whole address might be considered a composite attribute. The street address, the city, the state, and the zip code are four attributes associated with that one composite attribute. So they often make a distinction between a simple attribute, which is an attribute composed of a single component, and a composite attribute, which can have multiple components. A name is another example of a potential composite attribute. A name may have a first name, a middle name, and a last name. So oftentimes a name is considered a composite attribute. Now, orthogonal to that is the notion of single-valued versus multi-valued attributes. So a single-valued attribute can have only a single value for that type, whereas a multi-valued attribute could have multiple values for that entity type. Telephone numbers are a common example of a multi-valued attribute. They can have one or more. Another common example is children or dependents. You can have 0 dependents, you can have 1 dependent, 2 dependents, 3 dependents. So dependents or children are often multi-valued attributes. And as an example where you have both, children would be a multi-valued composite attribute because the names, the children have first and last names. That's a composite attribute. And then there's multiple children, so that's an example of a multi-valued composite attribute. So you have that on one axis, you have composite versus, what I call it, simple. And on the other axis, you have single-valued versus multiple-valued. Okay, and then we're going to add a third axis, which is derived or not derived. So a derived attribute might be something like staff count, the number of staff at each branch, or property count, the number of properties managed by each staff, or average salary per branch. Those are all derived attributes, which are not explicitly represented in the database. So there's actually 3 dimensions to attributes. Okay, now there's an issue with multi-valued attributes. What is the issue with multi-valued attributes in the relational model? Think back to chapter 4. They're illegal. You can't. So back in chapter 4, if we go back to chapter 4, let's do that very quickly. Prove it to you. When we're back in chapter 4, properties of relations. Okay? Number 2. Each cell of a relation contains exactly one atomic value. A phone field may not contain multiple phone numbers. So back under properties of relations, the relational database model explicitly forbids multi-valued attributes. That's inconvenient because in the real world, there are definitely multi-valued attributes. Hey, well, there is a solution to that, which is you basically have to split the multi-valued attribute off into its own separate relation. So, for example, you might have a relation called dependence, which might have a staff ID and first name of the dependent, last name. And that way, a staff member could have 0 or many children. Same thing with phone numbers. You might have branch number and then phone number. Now it's okay because within phone numbers, while a branch may occur multiple times for any particular number, there's only one value for that number. So that's the solution when you take a multi-valued attribute and have to represent it in a relational database. You create a separate relation for it. So you would have something like branch and another one, phone number, maybe lists. The book has a name for this. They call these weak entities because that entity would not exist were it not for the so-called parent entity. So without a branch, there would be no phone number entity. So this phone number is would not normally be one of the entities that you would list initially. It would only be when you realized that you needed to have a multi-valued attribute that you would create a relation containing phone numbers. And in fact, you would not draw this in the ER diagram. This would not be part of the ER diagram. Instead, you would simply list it as a multi-valued attribute. Okay, so we talked about derived attributes such as property count or staff count. So in a really cluttered entity relationship diagram, you might show a composite attribute with indented. So address would not actually be represented as an attribute in the database. Instead, it would be represented as street, city, and postcode. But in your ER diagram, you would actually say address is an attribute, and then indent it. You would say what are the three attributes that form it. Here, it's a multi-valued attribute, telephone number, and in square brackets, you represent the participation rate. Here, there can be 1 to 3. For dependents, it might be, say, 0 to 20, or 0 to star, where star means an arbitrary number. So you wouldn't try to, an ER diagram doesn't exactly map directly into the relations that you come up with for your database. So telephone number might end up as a relation, but in the ER diagram, it's shown as a multi-valued attribute. The bookings relationship is shown as a relationship in the ER diagram, but a relation when you actually create the database. Okay, then derived attributes are shown with a slash in front of them. So this is something we might put into a view, but we're not going to explicitly represent in the database. So derived attributes are attributes that are not explicitly part of an entity. They're summary attributes. And then you can see that you list here PK for primary key. Now, this gets the entity relationship diagram pretty cluttered, so the ones you draw are only going to contain the names of the entities. They're not going to contain the names of the attributes. But a full-on UML ER diagram would include the attributes as well. Okay, and we've already talked about candidate key, primary key. A composite key is simply a key that consists of 2 or more attributes. Okay, and then the book talks about strong entity types and weak entity types. Really, from everything I can see in the book, whenever it's talking about a weak entity type, it's typically talking about a multi-valued attribute. So the strong entity here is client. They state some preference, but really preference type and max rent could also be attributes of client. Okay, so I take exception to the book using this notion of weak entity. Wherever I see weak entity, I just think multi-valued attribute. And it's not really an entity. So in this case, I really would have put preference type and max rent in with client and just indicate 0, ... 1 to indicate that they have 0 to 1 of that values for that attribute. Okay? Now, another thing about attributes is they can be associated with relationships. So in this case, we have a newspaper advertises property for rent, and an advertisement has some attributes associated with it, such as the date of the advertisement and the cost of the advertisement. So it's okay to have attributes associated with it. A booking relationship might have attributes associated with it. What are the attributes for a booking relationship? At a minimum, date from and date to are attributes for a booking relationship. So you represent those attributes with a dotted line. Okay, and again, you won't have to worry about that in the ER diagrams that you're going to be drawing, because we're not going to ask you to include the attributes in your ER diagram. But should you see a dotted line in a UML diagram, it means it's attributes for a relationship. Okay? Now, we come to constraints. Remember that a database consists of relations, attributes, constraints. So we must be able to specify constraints. And the main type of constraint on relationships is something that we call multiplicity, which is the number of times that an entity occurs in a relationship. So for example, with the branch-staff relationship, one branch may have, there can be multiple staff for one branch. So that's the multiplicity for that. And we typically talk about both the cardinality and the participation rate. So participation is the minimum number of entities in the relationship, and cardinality is the maximum number. So as an example, we might say that in the manages, a staff member manages 0 or 1 branches. So most staff members manage no branches. So that's the minimum number or participation rate. The maximum number of branches that a staff may manage is 1. In the opposite direction, a branch is always managed by 1 manager. So there's a minimum of 1 and a maximum of 1. So that is the multiplicity rates for this relationship. So there's always 2 for each side of the relationship. And if there's a ternary relationship, then there are 3. If there's a quaternary relationship, there are 4. Okay, so participation rate is minimum number, cardinality is maximum. Okay. And then we also talk about the degree of a relationship. So that's orthogonal to the multiplicity. So we have multiplicity on one axis and degree on the other. So earlier when I said that one branch could have many staff, I was talking about degree, one to many. Multiplicity is the participation factor. So participation and cardinality. The degree combines the cardinality on the two sides of the relationship. So it's takes whatever is the cardinality. So in the branch employs staff, we say that a branch has one to many staff, represented as a star, and a staff belongs to exactly one branch. So we say that the degree of this, it's a one-to-many relationship, because if we combine the cardinalities, we get a one-to-many relationship. Okay, so we have one-to-one. So an example of one-to-one is staff manages branch, because both sides of that relationship has a maximum of one. One-to-many, the example was a branch employs many staff, and many-to-many, such as students enrolled in courses. There can be many students in one course, and a student can enroll in multiple courses. So when you're trying to come up with these things, it helps to ask, if I'm saying staff manages, how many, what's the minimum number it can manage and the maximum number, and then you put that next to the dependent entity. So in this case, a staff manages how many, and conversely, a branch is managed by how many. So a branch is managed by a minimum of one manager and a maximum of one manager. Okay, here a staff oversees 0 to many properties. A property is overseen by 0 to 1 staff. Maybe when it's first brought in, it may not yet be assigned to any staff, or if a staff member resigns, then it has 0. Okay, here, a newspaper may advertise one or many properties for rent for us, and we may advertise a property in 0 or more newspapers. For example, if the property is leased, we're probably not advertising it right now, so it's being advertised in no newspapers. Whereas typically we only have a newspaper in our database if we're advertising in it. Okay? And just a final note for today, we'll pick this up on Tuesday. This is the wrong way to show a many-many relationship. Again, I often see this in ER diagrams. You say, you make the advertisement an entity, and you say the newspaper lists one or more advertisements, and you say the property for rent appears in 0 to many advertisements. And in general, if you have multiple arrows coming into a sync node, and advertisement is a sync node, you probably messed it up. And it's probably a relationship. So typically, sync nodes are usually relationships. So if you find out that you've drawn a sync node, give a lot of consideration to whether that really is a relationship rather than an entity. Okay? So we'll pick this up on Tuesday, and we'll go over a case study. I strongly urge you to read the case study before you come to class, even if it just takes you 5 minutes before class, or you'll have no idea what I'm talking about.